Hey everybody, welcome back to BOSC. Thanks for joining us again. And we're going to start with our open science session now. I know that Salvador and Mateusz and Julian and Ana Maria know that they are all that stand between you and lunch. So I sincerely appreciate you giving them your undivided attention. We're going to start with Salvador, and he's going to be talking about OpenEBench. Speakers, you have, for those of you with 20 minutes, you'll have a 5-minute warning, and then you will receive a 1-minute warning, and then you must stop. If I get out, I'll just grab you out of the podium. Speakers with 5 minutes, you'll just receive a 1-minute warning, and then you must stop. Thank you. Come in.
Thank you very much, and I will do my best to stick to the time because I don't want to get out of the here. So today I'm going to talk about OpenEBench, but before starting, I would like to introduce what we understand by benchmarking, because everyone has their own concept of benchmarking. So different users, and when we mean users, we have researchers, we have developers, we have even funding agencies and so on have different needs. So for instance, end user want to identify what is the best tool for the problem. No discussion. So I have this problem, I want to find the best tool, and then if I'm a PhD student, I want to justify to my boss why I have chosen this tool and not any other. If I'm a developer, so I want to identify what is the state of the art, so who are my competitors, what are the relevant data sets that I can use for basically benchmarking, so basically to compare against others, or I want to understand which metrics are being used to do those comparisons. If I'm a community, so as a community, and then we are seeing many of those here at the ISMB is, well, what are the challenges that our community we face? What are the data sets that we need to produce or we need to curate in somehow to move forward on those benchmarking activities? But also, as not only as a community, but let's say that we have funding agencies, we have policymakers, and so on and so forth. We want to understand what is the state of the art and what are the guidelines that we should put forward to somehow write the the adoption of standards, and so on and so forth. I'm sorry because I'm getting super confused with that many slides, so it's breaking me the whole flow. So, okay, so benchmarking. We are not doing anything from scratch. So what we have been doing the last 2 years is looking at the different benchmarking initiatives, starting by CAS in '94, and then building on top of that. So identifying what is relevant, what is common, what is different across all these different initiatives. And since then, we just have been proposing OpenEBench. So I would like to bring this picture from yesterday. What Christophe Desimos was talking about, benchmarking and a number of conclusions that we very much share with him, in the sense that benchmarking is not, you cannot capture the all complexity of a given field in a single metric, so it's, you need a variety of metrics and so on to capture all the complexity that you have. That is content dependent, and I will add also that it's a community lead effort. Because, of course, when we are doing computational biology, when we are doing bioinformatics, we want to publish our papers, we need to demonstrate that our tool is better than the state of the art. But that might be biased, because we tend to say, okay, in this very particular data set, I'm doing very well, or with this very particular metric, I'm doing very well, but is that relevant for the field, for the community? By having the communities, we just can overcome those problems. And we are not working alone. So we are working in the context of the tools platform, when we are a bunch of people working in different aspects of around tools. So we have, for instance, the services registries, the bio.tools. We have biocontainers, so that was the reason, because I was asking before about it, where we have a number of mechanisms to generate images and so on and so forth. We have benchmarking, and then we have mechanisms to execute those workflows associated. Not just as a platform, but we interact with other ELIXIR platforms, like data, interoperability, training, and so on and so forth. But the question is, what is ELIXIR? ELIXIR is a European organization that is at the moment with 23 countries and is distributed in Europe and beyond. This is just to bring everyone together and to make people work together and use the same standards and so on and so forth. And to do that, we are organized across platforms. So we have 5 platforms and different use cases. The platform sets the guidelines, the technologies, and so on and so forth. And the use cases or the communities are used to demonstrate that what we are proposing makes sense. Because otherwise, we can be proposing things that people are not adopting. Coming back to OpenEBench, that is how it looks like. There are 2 components. We have the scientific benchmarking part and the technical benchmarking part. In the technical part, what we call the technical monitoring, we have this information from different tools. And when I'm saying different tools, we're talking about roughly 17,000 tools that we are monitoring basically every day. And we are integrating information from different places and providing links to different sources, like here, like the bio.tools. What is cool about this part is, for instance, we are looking at web services and so on, saying what is the response time, that it might be relevant if you as a user want to use something that is not available anymore. So then you can have this that will be like 0, so it's not available anymore. And then we have information about the publications and so on and so forth. We have been working on that, and the new part here is like, well, many people have been talking about FAIR, right? Furfur Data. And now we are saying, well, we would like to work towards FAIR for software. And we have been doing a theoretical and a technical job. In the theoretical part, we have been proposing, well, how we transfer the FAIR data principle into principles applied to software, to research software. That is not that easy, especially in the part of interoperability and reusability. And once we have stated those FAIR principles for research software, how we start measuring them? How are we proposing metrics to measure how fair the software is? And that is an ongoing work, but we are capturing information from different sources, or like software registries, repositories like GitHub, papers. So we are going through papers, especially abstract, web pages, and other places like Galaxy Toolset. And then we are combining that information in something that we call Alambique. Then we harmonize the data, because we might have the same information coming from different sources, and generate some metrics. For instance, here is the very simple thing that 2,000 tools, the information that we have been looking at. And we have a description for most of them. We have, for instance, whether they have a publication or not and so on. But there are not that many with the GitHub. So it's something like, well, we're measuring these kind of things. And when we go a little bit forward and look the fairness of software, we're getting this. Software is really easy to find. That is fine. Okay, so they are findable. But then we have a different result when it comes to accessibility, interoperability, and reusability. And accessibility, seeing that we have like these two populations, but then interoperability is really difficult to measure, to capture all the information, and that is really difficult to let's say, be interoperable. And the part of reusability has to do a lot with whether it's documentation, how you use the software actually, even for the own author, 3, 4, 6 months later, how they use it. So that is a way to show to the author, basically you, for instance, and to developers, how fair is your software and how propose ways that you can improve it. But let's move on to the scientific part. So as I was saying before, the scientific communities are key to us. So why are key to us? Because the scientific communities can propose data sets either as an input to do the benchmarking and also for the golden data set. So the data set that people can use to do the benchmarking per se and the data set that people can use to compare with. Then we have the metrics, which one are the relevant ones. And then we have the interpretations. Once I have that data, how I can interpret that. And that is the reason because we have been working with different communities here. So you can always bring your own community and be part of it. And we are really happy to be working with all these people. Of course, we go much slower because then you need to consult, you need the TCs and so on and so forth, and looking people in the audience that we have been calling in. But we are producing something that is really useful because one of the risks when you're producing an infrastructure is that you have a super cool infrastructure that no one is using. So better to go slow and secure. And then I have the dream challenges because it's something that we are exploring at the moment, how to work with the dream challenges that have already happened, how to bring that information in OpenEBench and make it available to everyone, that they can use it, so have this part alive. And then to explore whether in the future we can host directly the dream challenges in the platform. And to do that, we are proposing an architecture of 3 levels. Basically, level 1, that is the easy one, is how to import data that you have already generated, benchmarking data, and then you visualize that data. And a part of importing and visualizing data, that data is archived, so in a DOI, so it's no problem now, well, my postdoc is leaving, where is the data, and so on and so forth. That is all automatized. Level 2 is the one where you basically compute at your own place your predictions and so on and so forth. You send those predictions to us, and then we compute the metrics for you. And then we have, once the metrics are computed here using this workflow, that is sort of a standard way to do it, then we feed it to level 1, you can visualize it, you can play with that, and so on and so forth. It's in somehow a real-time benchmarking evaluation. Of course, it's not the same to send 1 megabyte file that if you're saying 10 gigabytes of results. So sometimes it might take a little bit time, but I will still call it and real-time evaluation. And finally, we have the level 3, that is the most interesting one. That is the one that at the moment we have just prototype, where you just submit the workflow, where you just submit the container, and we run it for you. So in that sense, you don't see the data. That is good because sometimes you have sensitive data, let's say a human patient, that you cannot see that data for privacy things, for privacy issues, or maybe because it's data that haven't been published yet, but you want to use it for benchmarking. So that will facilitate a lot the benchmarking part, and also to make a fair comparison, because then it's just not the scientific performance per se, but also the technical performance. To understand whether to be the best in a given challenge, you need to have a supercomputer behind you, or just a laptop. So we start capturing other different parameters. So basically, when we do level 1, it's something like this. So there is quest for orthodox data. We have a specific category where we have all the results. That sounds easy if you're an expert. If you're not an expert, probably you prefer something like this, where you can interpret which ones are the categories, where are the tools that you should be looking at. For instance, these ones. The ones here are the best performing ones. So we offer these expert, non-expert views, level 1, and then, of course, we offer the overview, the how things are organized for the different categories. Because remember, when we do benchmarking, we don't have a single metric, we don't have a single challenge that capture all the complexity. And then we have different challenges, and then how a given tool is performing. So this one is performing quite well. They should give me some money to put here then the best ones. But then you can always look for some of them that are performing specifically well for a particular case. So then if the user can say, do I want something that is doing well across the different categories, or do I want something that is doing very well for my particular case? It's up to the user. So we offer all this information. So I was saying, level 2 is there is a more real-time interaction with the user, so then you can change your parameters, submit again, and see what is the evaluation. And to do that, we have this workflow. So we validate that what you are submitting to us makes sense. So you have the same IDs, you have the right formats, and so on and so forth. We have metrics that has been proposed by the community. So we just here supporting that process. And finally, we have the consolidation. If you have different metrics, how to put everything together to facilitate the comparative analysis. And that is sort of a standard. We have a template that we are curating as we move with the different communities and so on and so forth. Importantly, we are using Docker containers. So I think everyone is familiar right now with Dockers and software containers in general. And we're running that using NetFlow. In that sense, we can move around all the computation, and even the communities, they deploy themselves the workflow, they prepare everything, and once everything is ready, we import that to OpenEBench. And we import that into the BiPto Research environment. It's a place where you have your user, your account, and then you can put there your data and so on, and then see how well you are doing for a specific benchmark. In this case, we have an example. We have a number of examples. Some of them are coming. So, for instance, Quest for Orthologs will be soon available here. And the BiPto Research environment, when you submit the data, look like this. Basically, similarly to what I was showing before, the level 1. But here you can play a little bit like what is the impact of removing or putting a different participant, or what happens if I'm changing some parameters and making the resubmission. And this case, for instance, has been inspired in this work by the TCGA, the Cancer Genome Atlas. So there is a consortium looking, for instance, around cancer driver genes and so on and so forth. So here you have the URL, the link. Although I was checking like 10 minutes ago, and I don't know what is the problem with the network that I think was down, but that I guess is the demo effect. So finally, we have the level 3 that we don't want to do this alone. So basically, what we're doing here is using using what is a European project called EOS Live, where we have all the different research infrastructure that try to work together with same standards and everything. So here, basically, it's just to use a repository for workflows where we have data provenance. So we just say we're benchmarking a specific configuration, but then if the user likes it, they can there grab it. So they say, okay, here is the workflow with the containers, and they can deploy it locally, or they can deploy it in any cloud instance. Okay. And that is, oops, I'm missing one slide here. So, we want to use that. So to move forward to that level 3, where users can basically, the developers can submit the workflows. They measure their they measure the performance of the tools and the solutions, and users can get there, and compare, and choose. Just to finalize, because today is not my day, because I have an internal clock here that is much faster than the 5 minutes that you showed me. Just to what we are doing after the ELIXIR Accelerate. ELIXIR Accelerate has been the project that has been funding this platform. We're looking for a production model where we work together with scientific communities to, on one side, develop the workflows, identify the data sets, and so on and so forth, but also to develop, in general, OpenEBench. So we want to have a platform that is in somehow a little bit of everyone participating on it. We don't want to have our own platform. It's just open to everyone. That is the reason because all our software is open, is licensed. When we submit the abstract, one of the referees was saying, well, where is the licenses? And well, we have 20 different repos, all open and all with the licenses. If I have to put all of them, probably the abstract is going to be just the repos. Then we are being considered by the European Commission, the European Research Center, as a platform for developing a policy for NGS used for antimicrobial resistance. So they want to say, well, if you want to be in the market, you need to comply with this minimum requirement, and the way to do it is just to demonstrate that you are doing it in OpenEBench, so this publicly available benchmark. And finally, as I was saying, our plan is to host some dream challenges. So we are working with some partners that are familiar with dream challenges and how to host that, how to work towards basically, there is a sentence that I tend to forget, the wisdom of the crowd, so how collectively work on that and then move forward, especially when they are not golden data, as I were, especially when they are not ground through. Say that, I just want to finalize thanking everyone that has been involved across the 2.5 years of the projects, and I invite you to be part of this slide, of course. Thank you.
Thank you, Salva. Do we have any questions? None online. Any from the floor?
Oh, yep.
Could you please come to the mic?
Only across the room. This is working? Yep. Okay. So I'm involved in a development project where basically it's heavily machine learning centered and rather than algorithmic. And it seems that we've been looking at OpenML as hosting our development process in an open way like you're doing. Mm-hmm. Have you talked to them? Have you looked at them? Because many people are moving in the machine learning direction for tool development.
Okay. To be honest, no, we haven't looked at them, but will be good to, if we can speak. I mean, we have been collaborating with different initiatives and so on. That is the reason, because of the Dream Challenge, that people were saying, they might be your competitors, but at the end of the day, we're looking for ways to collaborate. Why is that? Because usually benchmarking is something that everyone does, but no one really wants to invest in or even fund that. So just working together and in somehow having sort of a collaborative or federated model that will help a lot the field.
Thank you.
Thank you.
Let's give a round of applause.